about what I saw in your deliverable report. Practically, no team had an introduction. In any report, there should be a brief, short, okay, introduction about what is in the report. Okay? There should be, talk about 5 lines, 3 to 5 lines, something like that, okay? Not a big deal. More important though, I saw only a few things, give sources for what you're presenting. This doesn't need to be stated, guys. You're producing a report and you have data from somewhere, you need to immediately identify where you got it from. Have teams that listed 30 reactions without a single source. How do I know that you didn't make them up? Seriously. Okay? So you should always include sources. Prices. Where did you get them? So use your common sense about what is required. I'm not, on purpose, I'm not giving you any specific structure for every report. You need to develop your skills of reasoning out what would make a well-organized report. Okay? There are many ways of doing that. I don't want to pigeonhole you to one structure. But make sure that things that should be there are, and if you're identifying literature, reactions from literature, it's a no-brainer that you should have next to each reaction a number and have a list of what those numbers are, your references. Same thing, if you're getting prices, there should be a number next to each price. Where you got it from? Okay, clear everyone? Yes?
Do you want to just put like links?
You can choose how you put your references. But a reader of yours wants to check this price should be able to follow your link and see, okay, I see that price there. I see the reaction there. All right? And nevertheless, most things is a really good job. Yes, actually.
If we find the cost off of the website that you gave us, are we still expecting?
Yes, sure. If everything is from the same, you can have a little sentence, all prices are from ICIS. Then that's fine. But that was not the case. All right, clear everyone? Yes?
Do you want them to be like actively cited or do we just have a list of links?
I'm leaving it up to you. Okay? Anything rational is okay with me. But it makes common sense. If you're presenting prices, you would identify where you got its price from. As a matter of fact, that's part of what I'm looking in grading your reports. Did you go outside ICIS and Sigma Aldrich? Okay? Any other questions? Okay.
I went to the Texas downloader or like install.
Aspen, okay. So, Aspen and HYSYS, yes. So, how many of you have successfully installed Aspen and HYSYS? Okay, I'm saying a few hands, only a few hands. I'll tell you something. My instructions did not work on my computer. It worked on the computer I use in my office, but on my other laptop where I tried to put it, it didn't work. So I'm getting from Philip, I did one of our two IT staff, both of them, by the way, both Philip and Victor are really, really good guys. We're very lucky to have them. So anyway, Philip will send me updated instructions that hopefully will have greater chance for success. More complicated otherwise. So if what I gave you worked and worked fine in one of my two machines, okay, great. If it didn't, I should have those reactions later today uploaded, those instructions later today uploaded, okay, and try to have Aspen and HYSYS both installed together, installed before Friday's class. Again, we'll continue with HYSYS with the homework Friday, and the next step in the homework is Aspen. Any other questions? Yeah. Okay. All right. I can start by discussing deliverable form. Actually, let me discuss deliverable form after the break, because continuation of the lecture has to do with what you are going to be doing in deliverable form. Okay. Any other questions? All right, so we've been going through an example of not all the way to everything you're doing in your project, but at least the beginning of what you're going to be doing in your project. And that is making 800 million pounds per year of ammonium chloride. And we'll continue with the next step. And the next step in the instructions has the title in your text. So, in terms of listing the steps, I put a 0-step, I believe, figuring out if it's going to be a batch or a continuous process, right? Step 1 was deciding on the chemistry. And the next step is deciding on flow streams, what you're going to be recycling, if you're going to be mixing anything. So figuring out the flow streams is the next step. And I will continue with our example in Unison. So we're going to do that step right now. But the camera is plugged in, right? All right. So load up where we had stopped last time, where we modeled the two reactors. Okay? We modeled the second reactor, which was the cracking, and then the first reactor, which was the chlorination of ethylene to make dichloroethane. Okay, so I remind you in the ammonium chloride what we were. We first modeled the second reaction, which was the cracking of dichloroethane. We specified we then adjust the desired production of vinyl chloride, and that helped us figure out how much vinyl chloride we needed to bring, sorry, how much dichloroethane we needed to bring into reactor 2. And then we did a second adjust to produce that much dichloroethane. We figured out how much ethylene we need to add, we need to be feeding, and we set that chlorine is going to be equimolar. Okay, since we need 1 mole of ethylene and 1 mole of chlorine to make 1 mole of dichloroethane. And we also know how to do tables, and we see here the flows. And by the way, this is again, I'm mentioning an example from your text without the Unisim association. So I'll have here on the class website posted something we're going to be looking at. So the next step I have here a few pages from the first edition of your text. Since I don't trust my drawing skills. It takes a long time to load 3 pages of PDF. That is just 3 pages of PDF. That's good stuff.
It's web neutrality. I'm just kidding.
All right. Hopefully the load that sounds like. So we figured out the flows that we want to feed. The next thing is to figure the flows what we're going to be purifying, and the flows, the official nomenclature that your text uses is distribute chemicals, but basically it boils down to figuring out what you're going to separate and what flow streams you're going to have. Our first reactor has 98% conversion. That's pretty good. So we can, one possibility is we put a separation apparatus with the distillation column or something to the product and separate the dichloroethane from the unreacted ethylene and chlorine. It's not going to be a difficult separation, but it's already 98%, so probably this is not needed, so we can make the strategic decision that we are not going to purify this stream. So if we're not going to purify this stream, we're going to feed it directly to reactor 2. Now reactor 2 has conversion only 60%. What did we put? 63%. Only 63%. So that would be losing a lot of dichloroethane if we don't recycle. And obviously we want to have the separation anyway because we want to get our vinyl chloride pure out. So it makes sense that I will put some kind of separation apparatus here and recycle the unreacted dichloroethane, plus we will have to also, if we want high purity, probably also remove the leftover vinyl ethylene and chlorine. Okay? So we want to put it all together without at this stage actually doing the design of the separation process. We can specify close to ideal separation. In this case, I'll specify ideal separation. But so we're going to do this. We're going to use some tools that Unison provides. One thing to note is our string here, V1, is at, I believe, 90 degrees C. I mean, we can quickly, by hovering over it, you can see the temperature and pressure. So it's at 90 degrees C, and we have pressure 1.5 atmospheres. This is the feed to reactor 2 is 500 degrees C and 26 atmospheres. So obviously we cannot use, even if it has the right mass flow rate and species flow rate, we can't just hook this up to this one because the pressure here is lower than the pressure here, so we wouldn't be able to flow in, right? We can leave the temperature there, we don't have to necessarily preheat it, but that would make the heating duty of the reactor even higher. It's an endothermic reaction, so we need to provide heat. So at this stage, we can use some magical heaters and coolers that Unison provides. And in those, we can specify any temperature going out and any pressure going out. Later on, we will have to replace it with realistic units, pump or compressors to increase the pressure, heat exchanger with heating fluid to increase the temperature. But at this stage of the design, we are just going to use our magical heaters. And let me see if this uploaded. No. Okay. I just downloaded. That's faster. Let's save file. I forgot that I had to do that. So, and then just open the download file. So this is so this is, and let me make it a bit bigger. Why did it rotate it? Just Control Shift plus. I can click this. So this is from your text, first edition. Notice that all the units that you use are pounds per hour. And we're going to build this diagram, okay, that will show the flows, and we'll have the fresh feed and everything. Now, I've been doing everything kilograms per hour. It's going to be a big job to translate it to pounds per hour. All we're required to do, all we have to do, is go to a simulation and go to Tools, Preferences, Variables, and change the preference from SI to fill units. And exit that. And we lost our tables, but if we hover over, what do you see?